I am Dr. J.B. Kamble, presenting lecture number 5. Today's lecture we are going to cover some topics. Topics are determination of reduced level, height of collimation method, and rise and fall method, and some numerical problems related to these two methods. First, we should know what is determination of, or how we are determining the reduced level. What is mean by reduced level? Whenever any leveling is to be done or is carried out, the first reading is taken on a point of known elevation is known as, or is called as, a backside reading. Then when we are shifting our instrument from one place to another place after taking the reading, so the next reading which will be there is known as foresight. Means, in other words, before shifting the instrument, one reading is taken on firm object whose elevation is to be determined is known as foresight reading. And between this backside and foresight readings, we are taking other reading, and that reading known as intermediate sight reading. All these readings are required to be tabulated and converted to reduced level for the practice. So we are going to see how and which methods we are using for determination of reduced level. We'll see here what are the methods which we are using for determining the reduced level. First one is there, the collimation or height of instrument method, and the second one, the rise and fall method. So we will see here the collimation method. In collimation method, at the first reduced level of the plane of collimation means height of instrument is calculated for every setting of the instrument, and then reduced level of different stations are recalculated with reference to the height of the instrument. In the first setting, the height of instrument is calculated by adding the backside reading with the reduced level of the benchmark, by subtracting all the readings of all intermediate sites and that of the first change point from the height of instrument. Then their reduced levels are calculated, and then new height of instrument is calculated by adding backside reading with the reduced level of the first change point. This process is repeated till the entire area is covered. Then we are moving towards arithmetic check of the method. So in this method, the difference between the sum of backsides and the sum of foresight should be equal to the difference of first and last area. Next method, that is the rise and fall method. In this method, the level reading taken on different stations are compared with the readings taken from the intermediate preceding stations. The difference in the readings indicate rise or fall depending upon whether the stop reading is smaller or greater that of the preceding reading, and then the rise is added, fall is subtracted from the reduced level of a station to obtain the reduced level of the next station. Again, in this system or in this method also we are doing arithmetic check, but here the arithmetic check, when we are doing it, the difference between the sum of backside and the sum of foresights is equal to the difference between the sum of the rise and fall, and it should be equal to the difference between first and last area. How we are calculating when the reduced level of A is known and we have to find out the reduced level of B. We are using this relation, the relation reduced level of B is equal to reduced level of A plus backside minus foresight. If reduced levels of intermediate points, if we have to find out, then we are using another relation. That relation is reduced level of point is equal to reduced level of benchmark plus backside minus intermediate side. The difference of level between A and B is equal to the algebraic sum of the difference, or equal the difference between the sum of backsides and the sum of the foresight. If the difference is positive, it indicates that the point B is higher than the point A, while it is a negative, the point B is lower than the point A. These two methods which we have discussed now, so we'll see how the problems or numericals or field observations we are using for calculation of the reduced level. So this is one example, we're going to take it here. So I will read the example first. The following consecutive readings were taken with the dumpy level 0.565, 0.854, 0.940, 1.005, 0.640, 0.660, 0.785, 0.800, 0.635, 1.135 and 1.420. The level was shifted after the fourth and seventh readings. The first reading was taken on the benchmark of RL is 100.565. Calculate the reduced level of the change points and the difference of the level between first and last. So here is the solution for this numerical. So here these are the given values starting with 0.565, 0.854, 0.945 and so on, and reduced level is given is 100.565. When we are using first method, that is a collimation or height of instrument method for calculation of reduced level, then we have to make the table. In the table we have to make first column of stations, then we have to enter the readings which we have taken during the practical or taken by using dumpy level readings, that will be in meter, backside, intermediate side, foresight, then reduced level of plane of collimation, that is in other words height of instrument in meter, reduced level in meter, and then last column will be there, that is a remarks column. So we'll see. So when we are having the table for the height of instrument method, after preparing this table we have to enter the readings. Readings we are having here, that is given in numerical. So first reading which will be there, so we know the backside means what, the first reading which is taken by the instrument, and that we have to enter in station A. Before going to enter that at station A, so we are having value of reduced level, and that is we have to enter at this column, this spot here 100.565, then reduced level will be there 100 and benchmark, that is point, it is for the 100, and that is we have to enter in the remarks. So we'll begin the entry of the readings. First one for the A we have to enter here, so that is a 0.565. If you take this reading here, reduced level will be 100.565. If you minus 100.565 and 100, so we'll get this value 0.565. Then we have to enter the immediate reading which is taken after backside into next column, and that column is intermediate side column, so that is for the station B next. So here when we are reducing the value of intermediate side from reduced level value, so we'll get the reduced level value. So here for the reduced level value, when we are minusing intermediate side from this value, so we'll get the 99.715. Similarly for the next value, that is 0.945, we have to enter here in C station, so value has entered here 0.940, and after doing the minus from this reduced level of collimation, so we'll get 99.625. Then next reading is there, that is a 1.005, that we have to enter at the next station. So that reading we have entered at the foresight. Reason is that, so we have shifted our instrument after fourth reading, so we have to enter that reading in foresight. So when we are shifting our instrument, so that reading will be the last reading, and that last reading always we are entering the foresight. So again we have to, this 1.005 value we have to minus from the 100.565, and we'll get the this reduced level value 99.560. Here when we are shifting our instrument, so that point is turning point or change point 1, so we have to write in remarks column. Then we have to move to the next reading, that is 0.640. So if you see here, that reading we have entered in same station but in BS side. Reason is that when we are shifting our instrument, we have to take backside reading and then we have to move further. So here when we will add this reduced level plus backside reading, so we'll get the new RL of plane of collimation. So this value we got it after adding 99.560 plus 0.640, and here that value 100.200. Then we are moving to the next value, that is 0.660. So here in next station we are entering that value, and that value is again 0.660. This value we have to minus from 100.200, we'll get the reduced level value 99.540. Then for the next station, similarly we have to move 0.785. That value we have to minus from 100.200, and we'll get the next reduced level value, that is 99.415. So this point is a change point 2 or turning point 2. So we in problems or in numerical it was given that, so we are shifting our instrument after 4th reading and 7th reading. So that is why this value it is coming in foresight. Then we are moving to the next entry. Here when we have shifted our instrument, again we have to take on the same spot, we have to take another reading. That reading will be 0.800, and it will come under backside reading. Again the reduced level which we got it after doing minus from 100.200 minus 0.785, this value of reduced level we have to add in backside reading, and we'll get the reduced level of plane of collimation, that is 100.215. And then we have to move to the next station. So next station will be there, station G. So we have to enter the next station value after BS reading. We have to enter into the IS. The value is 0.635. Again this value we have to minus it from 100.215, and we'll get next reduced level value, that is 99.580. Then we have to move to the next value, that is given 1.135. that is for the next station. It is also coming under IS column only. So here again this value 1.135 we have to minus from 100.215, and that reduced level which got it we have to enter here 99.080. Then we are having the last reading, that is 1.420, that we have to enter in FS column or foresight column, and that is the last station. Here we got this value 1.420. So again similar to the other readings, 100.215 minus 1.420 will get 99.795, and that is our last point. So last point we have to mark it in remarks column, we have to write in remarks column. Then after doing these entries and calculations for the reduced level, we have to go for the arithmetic check. When we are going for the arithmetic check, do summation of BS and summation of FS. So here we have done summation of BS, that is 2.005, and summation of FS is equal to 3.210. So how we are doing this arithmetic check? Arithmetic check means the difference between the sum of backsides and the sum of foresides should be equal to the difference of the first and last RL. So here summation of BS is equal to 2.005. Then summation of FS is equal to 3.210. Here first RL is 100 and last RL is 98.795. Here the formula is for arithmetic check, summation of BS minus summation of FS is equal to last RL minus first RL. Here summation of BS is 2.005 minus 3.210 is equal to 98.795 minus 100. So here the value is 1.205 is equal to minus 1.205. The value is checked and our readings or observations which we have taken it correct. Now the next method. So this method also similar to height of instrument or plan of collimation method, but the only columns that they are changing here, in place of height of instrument column, here we will be having rise one column and fall another column. All other things, all other values will be remain same. Here reduced level value which will be there at benchmark point 100, and here backside reading which we have taken the first reading, so that is 0.565. so that is we are entering at the station A. Then similar to height of instrument method, here also the next reading which is taken after backside reading we have to enter in IS column. So here we have entered in IS column, that is a station B. When we are calculating reduce level and fall or rise of rise and fall method, then what we have to do, we have to make minus the next reading from the first reading, or we have to make the next reading minus from the previous reading. So here this is the previous reading or the first reading, 0.565 minus 0.854, and it is coming minus 0.289. so we are saying it fall, it is not writing as a minus 0.289, but we are writing in place of fall, and that value is 0.289. when we are making minus this value, fall value, from a reduced level value, that is from 100, so it will become 99.711. Similarly, for the next reading that we have to enter in IS column, 0.940. again from this previous reading we have to make minus the next reading, and the value is 0.86. again this value we have to make it minus from the reduced level, and so it is become 99.625. then next reading again for the next station, so 0.940 minus 1.005, this value will be coming under fall, 0.065. so when we will minus this value from 99.625, so this value will become, or reduced level will become 99.560, so that is a 0.1. then next reading which is coming after the foresight reading, so we have to enter into the backside. So here we have entered it. Similar to that we have to do it, 0640 minus 0660, it will become 0020, and when we are making minus from the reduced level value of this, so it will become 99.540. then for the next one, so that value will come in foresight, that is a 7th reading, 0.785. again we have to make it minus from the 0.660, and that value we have to enter in fall, because it's a minus value, we have to enter in the fall. again this value, fall value, we have to make it minus from the reduced level from 99.540, and then value it will become 99.415. then next reading we have to enter it again in backside, and the next value which is coming, so that we have to enter in the IS column or in the intermediate side column. then when we are making 0.635 minus from 800, it will be the positive and it is a rise, so that is why we are entering in the rise column. Similar to this, so when we are taking it as rise, so here rise we have to add into the reduced level value, because it is a plus value, we have to add into the reduced level value, and next reduced level value it will become 99.580. next value for the next station, so we are entering at 1.135. again this same we have to do, we have to minus 1.135 from 0.635, that value will become 0.500. again from this 99.580, 0.500, it will become 99.080. for the last reading, that is AFS 1.420, it is coming station I, and same we have to do this value, we have to minus from this value, and it will become 0.285, that is a fall minus value. again 99.080 minus 0.285, it will become 99.795. so this is our last point, last reading. For this method, when we are doing the arithmetic check for rise and fall method, so again we have to do summation of BS, summation of FS, summation of rise, summation of fall. So here the values for the summation of BS 2.005, summation of FS 3.210, summation of rise 0.165, summation of fall 1.370. Here the arithmetic check for the rise and fall method. Here how we are calculating it. The difference between the sum of back sides and the sum of four sides is equal to the difference between the sum of rise and fall and should be equal to the difference of first and last RL. Here we are having summation of BS value 2.005 and summation of FS value 3.210. First RL 100, last RL 98.795, rise 0.165, fall 1.370. These values are there for BS and FS. 2.005, 3.210 is equal to 0.165 minus 1.370 is equal to 98.795 minus 100.000, and it is checked and all values are equal 1.205. We are having one study example. This example you have to solve and you have to submit it as a assignment. So this similar to that example. Here the following consecutive readings were taken with the dumpy level, and these are the readings. The level was shifted after third and sixth reading. The first reading was taken on the benchmark of the reduced level is 100.405, and calculate the reduced level of the change point and the difference of level between first and last point. Thank you friends.